Look at how to find the roots of a quadratic function or a quadratic equation. Just very simple to go. Okay. Now, assuming you are given a function or you come across a certain function or an equation where you have ax squared plus bx plus c giving you 0. Okay. So ax squared plus bx plus c equals 0. Now, in this, the first thing you have to do is to make what? The coefficient of x squared to be 1. So what do? We can divide through by what? A. So I have ax squared all over a plus bx all over a plus my c over a. Right, that's the first thing. But here, we know that this will cancel this. So I now have x squared plus b over a x. This is a constant, so I can decide to send it to the other side. So this will give me minus c on a. Now, with this, what do? We know that the coefficient of x, which is what? b on a, which is the coefficient of x, we'll multiply it by half, then we square all sides. Then whatever we have, we add it to both sides. So this will give me what? b on 2a all squared. So in that, we can put it here as my x squared plus b over a x plus b over 2a all squared. This is giving me minus c over a plus, now let's clean, plus b over 2a all squared. From here, this, we can put this together, having x plus b on 2a all squared. Right. Now here, we can simplify this guy, which will now be minus c on a plus b squared over 4a squared. When you square the 2, you get 4. When you square the a, you get a squared. So you get 4a squared. But here, we can do some simple algebra where we find the LCM. And then finding the LCM, we have 4a squared. And then your a into the 4a squared, you know that it will remain 4a. So the 4a multiplying the numerator will now give you minus 4ac. Now 4a into itself is 1. So 1 times b squared will give you plus b squared. Now this, we now put it back here. We are having x plus b on 2a all squared is now giving us b squared. We can rearrange it, b squared minus 4ac all over 4a squared. Right. So here, from here, we can try to do away with my square. So taking away the square, we have what? Let's divide this. We have x plus b on 2a all squared is giving me what? b squared minus 4ac all over 4a squared. Okay, all over 4a squared. Okay, now from this, we can introduce the square root so that we cancel our square. Right, so I'm having x plus b on 2a all squared is equal to this, right, which is giving you what? b squared minus 4ac all over 2a. So we know that this is either plus or minus, right? And then here it will take away the root sign. So I'm now having x plus b on 2a giving me what? Plus or minus the square root of b squared minus 4ac all over Okay, all over 2a. Now, this guy changed to 2a because the square root of 4a squared, this can be written as the square root of 2 to the power 2, a to the power square. So this is still just the same as the square root of 2a all to the power square. So the square take away the roots. So it's only left with what? 2a. So it means that here the root sign is no longer affecting the 2a. Okay. So it means that what actually we have here is x plus b over 2a, giving you plus or minus the root of b squared minus 4ac all over 2a. Okay, so here we know that we want to make x the subject, so you can transport this to the other side where we have our x giving you minus b on 2a plus or minus the root of b squared minus 4ac all over 2a. Now the denominators are the same. Since the denominators are the same, we can just focus on the numerator. So it means that we are having my x giving me minus b plus or minus the root of b squared minus 4ac all over 2a. Congratulations, here comes the formula for finding the roots of a quadratic function or the equation. So let's see, it means that my x1 can be what? Minus b plus the root of b squared minus 4ac all over 2a. Now my x2 will now be the change of the operational signs here, which will be minus b minus the root of b squared minus 4ac all over 2a. That is that. Thank you.